Okay guys, good morning. So after talking about consecutive integer problems, the next type of word problem we will look at, and this probably will be our last, at least for now, is what we call coin problems. All right, so let's recap what we did with our consecutive integer problem. So for number one, we've got 5 consecutive odd integers. So if the first odd integer is x, the next one is 2 greater, which is x plus 2, x plus 4, x plus 6, and x plus 8. Now, of course, it would make a little more sense, of course, to make the middle one x, because then all of the other constants will net out when we add the like terms, and we'll just get 5x. But if we do it this way, I've got x plus 2 plus x plus 4. The sum of those expressions is going to be 5x plus 20 equals negative 115. So I add negative 20 on both sides. I get 5x equals negative 135. All right, I divide both sides by 5. I get x is negative 27. And of course, we have to go back and substitute so that we can find our 5 values. So if x is negative 27, x plus 2 is negative 25, negative 23, negative 21, and negative 19. And if I add those 5 expressions, it will give me negative 115. Now, if you had made x the middle one, you're going to get x equals negative 23, and then when you go back and substitute into your expressions, you'll get the same 5 values. All right, so let's take a look now at the second one. So 3 consecutive integers, so we'll call them x, x plus 1, and x plus 2. And it says the sum of the first 2. Okay, so let's stop there, right? The first is x, the second one is x plus 1, and we want their sum. So x plus 1. It says is 14 more than the third. Right, that's pretty easy then. The third is x plus 2, and it's 14 more than that. So when I combine my like terms, I get 2x plus 1 equals x plus 16. So I'm going to add negative x on both sides, right, which gives me x plus 1 equals 16, and that's going to give me x is 15. So if I go back now and substitute, I get x is 15, I get x plus 1 is 16, I get x plus 2 is 17. So those are my 3 integers. If we want to check it, the sum of the first 2 is 31, and that's equal to 17 plus 14, which is also 31. So that's going to be our check. All right, so let's get started here. Johan has $3.40 worth of dimes and nickels. He has twice as many nickels as dimes. Okay, so a few things here, right? First, we generally want the variable to be what we have less of. So we're going to say we've got some nickels and we've got some dimes. So we have to decide which one of these is going to be our variable, right, our x. So we have twice as many nickels as dimes. So we have to think about what do we have less of. Well, I have the number of nickels is twice the amount of dimes, so I've got less dimes. Okay? And if the number of nickels is twice as many as the number of dimes, then my nickels are 2x. And it's very easy to get these confused, okay? Because we say twice as many nickels, and if we make x nickels, then we make 2x dimes sometimes, but that's wrong. How many dimes do we have? X. How many nickels do we have? Twice as many as the amount of dimes. So sometimes it requires reading the question a few times and kind of decoding what they're telling us. How many of each of these does he have? We're going to say, okay, well, we have $3.40. So the first thing that I'm going to tell you guys that I personally do is I do everything in terms of cents. I do not use any decimals with my coin problems. Okay, that's just personally how I do it. I've done this a long time, and that's, for me, what prevents mistakes more often than not. Okay, so let's see what's happening here, right? So I've got 2x nickels, and I've got x dimes. Okay? If I do 2x plus x equals 340, that's not going to give me a correct answer. And the reason it's going to give me not going to give me a correct answer is because $3.40 is the amount of money I have. 2x is not the amount of money I have. It's the number of nickels I have. How much money do I have if I have 2x nickels? Well, each of those 2x nickels is worth 5 cents. And what about those x dimes? Well, each of those x dimes is worth 10 cents. So when we're doing coin problems, once you use a variable to represent the number of coins you have, you're going to use as a coefficient or your multiplier the value of the coin. So 5 times 2x is 10x, and 10 times x is 10x. So 10x plus 10x is 20x. So when I solve for x, I'm going to get x is equal to 17. So if I go back here, my number of dimes is x equals 17. My number of nickels is 2x. Well, 2x is 2 times 17, which is 34. Let's answer the question. Okay, how many of each of the coins? He's got 17 dimes and he's got 34 nickels. Now we're going to say, does this make sense? Well, he has twice as many nickels as dimes because 17 times 2 is 34. And let's check our money, right? So 17 dimes is $1.70. 34 nickels is also $1.70. And if I add them up, it's going to give me $3.40, which is our check. So again, the important thing, and again, if I leave students to their own devices, every single time I do this lesson, someone's going to give me 2x plus x. And it makes sense. I understand completely why they would do that. So what we need to understand is that once you know the number of coins algebraically, you need to multiply the amount of coins by the value of the coin, and that's going to give you the value of the money. Okay, let's do a similar one. It says she has $1.90. She's got 4 more dimes than nickels. So she has more dimes. Great. Okay, so if we think about her number of nickels and her number of dimes, right, I think it makes sense to call her number of nickels x. She's got x nickels. How many dimes does she have? Well, she's got 4 more dimes than nickels. So if she had x nickels, she's got 4 more than that. She has x plus 4 dimes. So now let's go back, right? We said we're not going to do x plus 4. And again, guys, I omit the decimals. So instead of 1 90 hundredths, which is $1.90, I'm doing 190 cents. Instead of the coefficient of nickels being 0.05, right, 5 hundredths, I'm using 5 cents. For me, that makes things a lot simpler. So each of my x nickels is worth 5 cents. Okay, let me be consistent with my, actually, I'm going to do it, I'm going to put the parentheses like this. Let me take that back. I don't love that. Okay, so each of my x nickels is worth 5 cents. Each of my x plus 4 dimes is worth 10 cents. So now, of course, we realize that we're going to have to distribute, right? I have x nickels that are worth 5 cents each. I have x plus 4 dimes that are worth 10 cents each. So 5 times x is 5x. When I distribute my 10 to x and to 4, I get 10x plus 40 equals 190. So when I combine my like terms, I get 15x plus 40. So I get 15x equals 150. I get x is 10. So now I go back and I substitute. So if x is equal to 10, x plus 4 is equal to 14. So let's answer the question, right? Ashley has 10 nickels, and she's got 14 dimes. So let's check it really quickly, right? 14 dimes is $1.40, 10 nickels is 50 cents. Add them up and we get $1.90, which is exactly what we expected. All right, this one is going to be a little bit harder the first time. This is another one, right? Where if I leave people to their own kind of devices, maybe people can do this using a table or using guess and check or something like that, but doing this algebraically the first time is tough. So I'm going to say, okay, 24 total coins. So I'm going to think about dimes and quarters. So if I think about the different possibilities, and somebody said, well, suppose you had 20 dimes. How many quarters would you have? If you have 24 in total, you'd have 4. And my question is always, where did you get 4? And someone says, well, I did 24 minus 20. And I say, okay, well, what if you had 10 dimes? And everyone quickly says 14 quarters. And I say, great, where'd you get that from? And they say 24 minus 10. And I say, okay, cool. I said, well, what if you had x dimes? And then everyone looks at me. And I say, what's wrong? This isn't any different, right? Do the same thing you did. If I told you there were 20 dimes, you did 24 minus 20 to get 24. And if there were 10 dimes, you do 24 minus 10 to get 14. So if there's x dimes, I don't know why we shouldn't do 24 minus x. This is the key in solving a problem like this. Okay, and these questions are not very common on Regents exams and state exams because they're hard, okay, until we've done them. But if you know the total number of coins, you're going to say there's X of one type of coin and 24 minus X of the other type of coin. And it makes no difference which you use. So I'm going to say, I'm going to have there be X quarters. I'm going to do it a little bit on the reverse of what I did there. And I'm going to have 24 minus X dimes. Now, for those of us that are like, wait, does this really add up? What happens if you add 24 minus X plus X? Well, negative X plus X is 0. We just get 24. So that's proof that this actually algebraically does make sense. All right, so again, if there were 50 total coins, it would be X and 50 minus X. So let's solve the problem, right? So now we've got X quarters, and we have 24 minus X dimes. And that equals $4.65. Well, what do we know about my X quarters? Well, hopefully we know that quarters are 25 cents each. What do I know about my 24 minus X dimes? Well, hopefully we know that they're 10 cents each. So I've got X quarters at a value of 25 cents per. I have 24 minus X dimes at a value of 10 cents for each. So I'm going to distribute. I get 25X. And I get 240 minus 10X equals 465. Combine the like terms, gives me 15X. Add negative 240 on both sides. I get 15X is equal to 225. Divide by 15, we should get X is 15. Well, we didn't answer the question, right? So if X is equal to 15, 24 minus X is 24 minus 15, which is 9. Now, we still didn't answer the question. Well, X is the number of quarters, so I would expect that I have 15 quarters and 9 dimes. So 25 quarters is $3.75. My 9 dimes is 90 cents. That adds up to $4.65, right? That's our check. So let's see how we do with these two, right? Julia's got 280 worth of dimes and nickels, 6 times as many nickels. And then the second one is very similar to the last one, right? Instead of 24 total, I'm giving you 25 total. So you're going to pause it, and then we come back and we solve. So Julia's got 280 worth of dimes and nickels, 6 times as many nickels. Great. So I'm going to say she's got X dimes. She's got 6 times as many nickels. She has 6X nickels. So each of her X dimes is worth 10 cents. Each of her 6X nickels is worth 5 cents. And altogether, she's got 280 cents. Again, I do this in terms of cents instead of in terms of dollars. So I've got 10X plus 5 times 6X is 30X equals 280. So that's 40X equals 280. So X is 7. So if I go back, right, if X is 7, then 6X is 42. So let's answer the question. I've got 7 dimes, and I've got 42 nickels. So let's check it out, right? 42 nickels is $2.10, plus my 7 dimes is 70 cents. Altogether, that adds up to 280. All right, now let's see if we understood how to do the second one. So we got 310 worth of dimes and quarters, 25 total. So I'm going to say we've got X quarters, and I've got 25 minus X dimes. Now, if you had done it the other way around, it makes absolutely no difference. You're going to get a different value for X, but your answers at the end will be the same, and I will explain once we get there. So I've got X quarters that are worth 25 cents each. I've got 25X minus dimes, 25 minus X dimes, I think that's what I said. That's worth 10 cents each, and altogether I have 310 cents. So let's distribute. So that's 25X plus 250 minus 10X equals 310. 25X minus 10X is 15X plus 250 equals 310. So I get 15x equals 60. Divide both sides by 15, and I get x is 4. So to come back over here, if x is equal to 4, 25 minus x is 25 minus 4, which is 21. So again, let's answer the question. I've got 4 quarters, and I've got 21 dimes. So my 21 dimes is $2.10. My 4 quarters is $1. 2.10 plus $1 gives me 3.10. So there's our check. All right, guys, challenge time. So now we've got quarters, nickels, and dimes. Okay, so I'm going to use N, D, and Q, just because the video is already getting a little long, and that's okay. So let's see. She's got $2.40. She has twice as many quarters as nickels. All right, so I think I have my candidate here for x. So I'm going to say we've got x nickels. Twice as many quarters as nickels. Great, so her number of quarters is 2x. Now she's got 2 more nickels than dimes. Now this is where we have to do a little thinking. She's got 2 more nickels than dimes. So we can't put x plus 2 for dimes. That would mean she has 2 more dimes than nickels. So let's unwrap that sentence. If you have 2 more nickels than you have dimes, then you have 2 less dimes than nickels. So my number of dimes is x minus 2. All right, so let's think about that, right? The same way that if we said, if you wanted x to be the number of quarters, how many nickels do you have? Half as many, right? So we're not going to do it that way, but we can unwrap these things in a few different ways. But again, if we know that you have x nickels and you have more nickels than dimes, you have less dimes than nickels, in this case by 2. So let's look at our equation. I have x nickels at a cost of 5 cents each, or a value, I should say, of 5 cents each, x minus 2 dimes at 10 cents each, and 2x quarters at 25 cents each. And altogether that gives me $2.40. So 5x plus 10x minus 20 plus 50x equals 240. So 5x, 10x, and 50x is 65x. I'm going to add 20 on both sides to solve my two-step equation. So 65x equals 260. So I get x is 4. All right, this should be easy to substitute. If x is 4, then x minus 2 is 4 minus 2, which is 2, and 2x is 2 times 4, which is 8. So let's check it out. I think I should have 4 nickels, 2 dimes, and 8 quarters. So my 8 quarters is $2. My 2 dimes is 20 cents. My 4 nickels is 20 cents. Added up, we get 240. So that's our proof that we worked this out correctly. All right, guys, homework time. So numbers 1 and 2 are similar to the first couple we did. Number 3 is similar to that third one where you have 17 total coins, meaning you're going to have x and 17 minus x. Doesn't matter which one you use for which. And I'm going to say you can skip number 4. I would really like you to try it, but it's challenging for a few ways. One, it's got 3 types of coins, and one, it's got pennies. So when you substitute pennies, you'd have a coefficient of 1, which means you don't really need the coefficient. So if you can figure out number 4, that would be great. Post a comment and let me know so I know to check it out right away. And as always, guys, as you're working on these 3, or if you want to challenge yourself and try 4, any questions, comments, concerns, you upload your work, you leave me a comment, and you know that for the most part, I think I've been pretty good in getting back to you quickly, or at least as quickly as I can that day. So please continue to do that.